All right, so basically the area of a parallelogram is based off of the formula that you know for a rectangle. The reason it is if I were to take this little triangle on that side and slide it to this side, you would see that you have a rectangle, or, you know, some type of parallelogram of any sort. But the rectangle specifically is the one that you have learned as you've gone through school, base times height. And so for a parallelogram, which is just a version of a rectangle is just a version of a parallelogram rather, it ends up being the same exact formula. And so for any parallelogram that you have, your formula then is going to be the base times the height. Now you'll notice the height is not this side length here. The height specifically is the perpendicular from the top to the bottom, okay? So if you have the side length, that's not what you need unless it is a rectangle and that's a perpendicular. So you want to make sure in a parallelogram that you include the base and the height, which is the perpendicular distance when you calculate these. So if you flip the page, you'll see the example 1, finding the perimeter and the area of a parallelogram. And so what they've given you here is they've given you 18 inches, which is going to be, since this is a parallelogram, is going to be the length of this as well. And they have given you this right here. That is not the height. They have given you the side length. Now the side length is going to help you in perimeter. So perimeter is rather easy. If I were to do the perimeter of this, I'm just going to add 18 and 12 and then 12 and 18 again. And so finding the perimeter is easy. I'm going to just say it's going to be 60, right? So if I were to find this particular perimeter, I would add 18 twice, right? And 12 twice. And so perimeter is very simple. I'm going to get 60. For area, however, I'm missing a piece. I actually need to know what this is right here in order to find the area. And so they have given me some information that's going to be helpful. 60 degrees is specific because it is a special type of triangle. What type of triangle if I have a 60 and a 90? What type of triangle do I have? 30, 60, 90. All right. And so they've given me the hypotenuse of a 30, 60, 90 triangle. Now, what do I know about a 30, 60, 90 triangle? Or what should I know about a 30, 60, 90 triangle? If this is my short side, my hypotenuse is what compared to my short side? Twice the short side. And what is my long side?
Multiplied by the square root of 3.
There we go. And so they've given me my hypotenuse. So then what is my short side? My hypotenuse is 12. 6. And what is the side that I'm actually looking for?
6 square root of 3.
6 square root of 3. So if I were going to find this area then, it would be my base, which is going to be 18 inches because those are the same. 18 times my height, which is 6 square root of 3. And if you put that into the calculator, it is going to be 187.1. Now, if you did not remember 30, 60, 90, what else could you use there potentially? SOHCAHTOA. You could use right angle trigonometry there if you wanted to find out the opposite side. With the hypotenuse, you could use sine. All right. It says the Warners are planning to recarpet part of the first floor. Find the amount of carpeting needed to cover the living room, den, and hall. Okay, living room, den, and hall. So they want specifically this one, and this one. All right. And so I'm going to have 3 different areas here. My den, they've already given me everything I need, 9 by 15, right? So if I want to find my den, I'm just going to multiply 9 times 15. All right. The hallway. Hallway's a little bit trickier. I know the height of my hallway, don't I? What's the height of my hallway based on this figure? It's 13. What about the width of my hallway?
5.
And how do I know it's 5?
Because on the top it's 35.
but they didn't tell us one way or the other. All right. Last one we're going to look at is coordinate plane. All right, coordinate plane, and then we're going to do some. So they've given us the vertices of a quadrilateral: -4, -3, 2, -3, and 4, -6. And then the last one, -2, -6. They have the first section as proving that it's a quadrilateral, which I'm not going to make you do. We've already done that in a prior section. But then they want us to find the area. All right, so to find the area, I need the base and I need the height. All right, and what they've done is made it rather easy for us. If I'm looking at my base, which two numbers do I need to look at to figure out what my base is? Yeah, so I need to look at my x's, right? Because it's moving left and right. So if I go -2 to 4, how far apart are -2 and 4? They're 6, all right? And then when I'm looking at the perpendicular height here, what do I need to look at? My y value. So from -6 to -3, what's my height going to be there? 3. And so the area is easy. It's going to be 18. All right, for the first one, is asking for perimeter and area. You should have gotten 28 feet for the perimeter and 39 square feet for the area. For number 4, 46 yards for the perimeter and 91.9 square yards for the area. And 5, 12.8 meters for the perimeter and 10.2 square meters for the area. The first thing you have to do is figure out the height, right? So we have the hypotenuse of our 30, 60, 90 triangle. Hypotenuse is going to be it's double the short side. So what is the short side? 4.5. So this is 4.5 square root of 3 as your height. So the base of the parallelogram is still 5 feet. That's what they gave you. 5 feet. 5 times 4.5 square root of 3 is what you should have done there. All right. For 4, if this is 10 yards, then this is 10 yards, right? It's a parallelogram, okay? And so to get the height, I need to find the side length. For a 45, 45, 90, how does my side compare to my hypotenuse?
It's like multiplied by the square root of 2.
Right, so then I need to divide this. So my side length here and here is going to be 10 divided by the square root of 2. So then you're going to say 13 times 10 divided by the square root of 2. So this is going to be 13 times 10 divided by the square root of 2. That's because if this is the side times the square root of 2, then I have to divide by the square root of 2 to get my side.
Is it okay if we simplify?
This 10 equals your side times the square root of 2.
Yeah,
Right?
Right.
So in order to find my side, I have to divide that by the square root of 2 to get my side. All right, for this last one, you should have gotten 1,170 square feet. Yeah, so you can do it. Honestly, it works out to where you could just do 15 plus 35 plus 15 times 18, right? Like you could do that if you want to. Or you can break it up. You could say 15 times 18 for this first one here. 15 times 18, and then 18 times 35, and then 15 times 18 again, and add it up if you want to. Or you could have just added the 15, 35, and 15. 65 times 18. It's the same thing. All right, areas of triangles, trapezoids, and rhombi. All right. You probably already know the area of a triangle. It's basically if you were to take a parallelogram and cut it in half, you get a triangle. And so that's where we get our formula, 1/2 base times height. If I were to take another triangle and put it a similar triangle or a rather congruent triangle on top of it, you would see a parallelogram. And so it's your base times height, but cut in half. So 1/2 base times height, which is the area of a triangle. And hopefully you have all done area of a triangle before. So page 602 has the first example of this. Find the area of a quadrilateral. And they give us this quadrilateral. And they tell us some information. XZ is 39. Okay, so all the way from X to Z is 39. H to W is 20. And Y to G here is 21. All right. And so they've given us, I'm going to make, and so you're just going to take the area of the two triangles and add them. All right. So because this is not really a regular figure, it's not like it's a parallelogram that they've given us, just a standard quadrilateral. We'll do the top triangle first. We'll say triangle X, Z, and Y is going to be 1/2 your base times your height. And then triangle X, Z, and W is going to be 1/2 your base times your height. All right, and if you add those up, get those two areas and add them, you will then have the area of the entire quadrilateral. Okay, so basically for a trapezoid, you have two triangles. So I have two triangles that have the same height, right? Because these are parallel lines. Trapezoid by definition has one set of parallel lines, which we know this because we've learned that this year. So the distance between parallel lines is never going to change, which means the height of those two triangles that you create when you cut a trapezoid from corner to corner, they have the same height. And so if I were to take the first triangle, let's say this one up here, and I would say 1/2 my base one times my height, that's that particular triangle. And then if I do this one on the bottom, I would also say 1/2 my base 2 times the same height. And what they do is they just factor that out. So they factor out the 1/2 and the, I should put those together, the 1/2 and the H, because that's common to both of those. So they pull those out. Think of factoring from algebra 1. And they're left with base 1 plus base 2. And that's your formula. If you look there at the bottom of page 602, that is your formula for a trapezoid. Your formula is the area ends up being 1/2 your height times the sum of base 1 plus base 2. 1/2 your height, base 1 plus base 2. And it comes from those two triangles, right? Yeah, it's coordinate geometry, but they're very kind and they give it to us right on where we don't even have to use the distance formula. If this were turned on the coordinate plane where it wasn't perfect little, from one to the other, then you would have to use distance formula for them. But they've given it where you don't really have to use distance formula. So if I were looking at the height of this entire trapezoid, I am going to go from -1 all the way up to 4. So what's the height of this trapezoid?
5.
It's going to be 5. And if I'm looking at the first base, we'll do this one up here. I'm going to go from -3 to +3, which is 6. And then the bottom base here from -5 to +6 is 11. And so my formula for the area is going to be 1/2 my height, base 1 plus base 2. So we have 1/2, 5 times 17, right? And there's going to be a decimal there when we do that. So area is going to be 42.5. Rhombus is actually a parallelogram, obviously. So if you have a rhombus and you have a base and the perpendicular height, you would use that. But there's one more formula for a rhombus that works for specifically only the rhombus. And it includes the diagonals. Your diagonals are not the same length, right? It's not like a rectangle. And so your area of a rhombus is also 1/2 your diagonals multiplied together. Diagonal 1 times diagonal 2. So you can do your base times your height if you have your perpendicular height of your rhombus. Or if you don't and you have the diagonals, you can do diagonal 1 times diagonal 2. So like in this case, I have this diagonal on this coordinate plane. I could calculate my height if I wanted to, but that would include the distance formula. And I could calculate my base, and that would also include the distance formula. Because if I want a base here, I'm going to use distance formula. And if I want a perpendicular height, I'm actually going to have to figure that out. And so because of how it's situated on the coordinate plane, it's much easier to do diagonals here because those are perfect. And I don't have to actually use my distance formula. I can just count the difference. So if I'm going to calculate this diagonal here, I'm going to go from 7 to -1. So this diagonal is going to be 8. And then if I want to go this diagonal, I'm going -1 to 5. And so that diagonal there is going to be 6. So diagonals are much easier in this case. The area of this particular rhombus is going to be 1/2 6 times 8, which is, of course, 24. And so there are going to be times when using the diagonal is easier based on the information that they've given you. And, of course, now that you know the formulas, you can back into other information based on what they've given you. This rhombus has an area of 100 square meters. Find WY if XZ is 10 meters. Well, they gave me W to Y. They gave me X to Z. All right, so they gave me X to Z here, right there. And they told me it is 10 meters. And then they gave me the area, right? So I'm going to set it up in my formula. Area equals 1/2 my first diagonal, which I obviously know, and then my second diagonal, which is what I'm looking for. All right, so 1/2 times 10 is going to be 5, and then what do I do with that? Divide 100 by 5, right? And so my second diagonal is going to be what? 20. Specifically 20 meters. 20 meters. Trapezoid. Trapezoid has an area of 250 square inches. Find the height. All right. And so for this one, they've given me the area, and I have my two bases. So again, I'm just going to plug that in. The area of my trapezoid should be 1/2 my height, which I don't know, base 1 plus base 2. You can go ahead and figure out all of this over here if you want to. 150 is 1/2 of, that's obviously 50, times my height. So this is going to be 25. And then just divide both sides by 25. Yeah, you'll get a height of 10. So 10 inches will be my height there. Postulate, which seems like it would be common sense, but they tell us anyway, congruent figures have equal areas. If everything is congruent on the formula, on the figure, then when you multiply it, it's going to have the same area. This quilting block is composed of 12 congruent rhombi arranged in a regular hexagon. The height of the hexagon is 8 inches. If the total area of the rhombi is 48 square inches, then find the lengths of each diagonal and the area of one rhombus. All right. So, the first thing is the total area is 48 square inches. So how many do I have there? If 48 square inches is all of them, how many do I have in there?
You have 12.
I have 12. So if I take 48 divided by 12, we assume they all have the same area because they told us they were congruent. Then what's each of them? Yeah, 4 inches squared is the area of each of them. So area of one is going to be 4 inches squared. They also told me the height of this is, the total height of this is 8 inches. All right, so if these are congruent rhombi here, then what's the length of each of those diagonals?
8.
The total's 8.
Wait, more.
Total 8. Yeah, it's going to be 4, right? Does that make sense? So if they want the other diagonal, then I know the area of one of those is 4 inches squared. That should be 1/2 one diagonal, which I just calculated, times the other diagonal, which I don't know. So what's my other diagonal? 1/2 times 4 is not a trick question. So my second diagonal is going to be what length? 2. All right, let's look at these. Number 4. 240. What type of figure was this, by the way? All right. Number 5. You just had to add up the two triangles, 499.5. And then number 6 was a trapezoid, 240 yards. So number 6, you're just going to do 1/2 your height, base 1 plus base 2. So your formula should have looked like this. 1/2. Your height is 12. Base 1 plus base 2. All right. Number 10, they wanted you to find the height. They gave you the other information. You should have gotten 10 there. 1/2 height times 20 plus 30 equals 250. And then for this one, they gave you the area, and they wanted you to find the other diagonal, S to U. Now in this case, which again, they actually listed it here, so you know this is 15 and this is 15. Okay.